In this problem, we're being asked to solve for y. So I know I should end up with something that looks like y equals whatever y equals. I also know it's a solve, so I know I'm looking for this. I also know I can solve because I have an equal sign there. The first thing I'm going to do is I'm going to find my least common denominator. And to do that, I need to factor each of these denominators. And then I can find my least common denominator. So with this first denominator, I know I have to have a y plus 4 times y plus 1. Here I have the y plus 1 already. So I need to multiply by a y minus 1. And then in this last denominator, I have a y plus 4. It's already covered, a y minus 1. So this is my least common denominator. It's important to find the smallest denominator possible because working with polynomials, if I'm multiplying polynomials, they can get very complicated very fast and become nearly impossible to factor. There are other ways to solve them, but factoring is much too challenging for almost anybody. I'm going to rewrite this with everything factored just so it's a little neater. Okay. Now what I'm going to do is I am going to multiply everything by my least common denominator. I can do that because I have an equation. If I have an equation, I can multiply both sides of the equation by the same thing. So I'm going to multiply this side of the equation by y plus 4 times y plus 1 times y minus 1 all over 1. And I'm going to multiply this side of the equation by y plus 4 times y minus 1 times y plus 1. Again, I can do that because both sides of the equation are kept equal. Before I do anything else, however, I'm going to distribute across this addition sign. So I'm just going to write down y plus 4 times y minus 1 times y plus 1 beside this fraction also. Okay. Yes, there isn't really quite enough room to see everything here. It gets a little crowded, but hopefully it'll work. Now, I'm making these look like fractions, so I make sure I can divide common factors. Everything has to be multiplied. Everything's multiplied. I'm okay. I'm going to divide out y plus 4 with this y plus 4. I'm going to divide out this y plus 1 with that y plus 1. That's going to leave me y minus 1 times 1 all over 1, which is just y minus 1. I'm going to keep it in parentheses. This is a plus. I'm just going to move it down here. Here, again, because these are all being multiplied, they're all factors. I can divide out common factors. I can divide out the y minus 1 with the y minus 1 there. I can divide out the y plus 1 with the y plus 1 there. That's going to leave me with 5 times y plus 4 over 1, which is just 5 times y plus 4. And finally, on this side of the equation, again, they're all factors. If say this were a a 4 plus x, I would put it in parentheses also, just to make sure it stayed as a factor and I didn't cancel anything I couldn't. I can now divide out this y plus 4 with this y plus 4. I can divide out this y minus 1 with this y minus 1 equals, because this is my equal sign, 4 times y plus 1, and again this is all over 1, so my new equation looks much simpler, even though the orange pen's a little hard to see. And this I know how to solve. Y minus 1 plus 5y plus 20 equals 4y plus 4. All I've done is distribute across those parentheses. I'm going to combine like terms. This will give me 6y plus 19 equals 4y plus 4. I'm going to have all the y's on one side, so I'm going to subtract 4y from both sides. I could move things the other way and subtract 6y from both sides, but that's going to give me a negative, and I just prefer working with positives. I am, however, going to subtract 19 from both sides, so my y's are all on one side, and my constants are all on the other side. So give me 2y equals negative 15. I want y by itself because it said solve for y. I'm going to divide both sides by 2. I get y equals negative 15 over 2. And one last thing I have to do. I've got to come back up here and look at my denominators and make sure that if y equals negative 15 over 2, I'm not dividing by 0. We're good there. We're good there. We're good there. Okay, so I've checked everything. I have not plugged it back in to see that it really works. You're welcome to do that. You do need to check to make sure you're not dividing by 0 with whatever your solution is. We call those extraneous solutions. And occasionally they get introduced when we're multiplying here by things that contain our variable. Thank you.